Good morning everybody. Today we are going to discuss about the topic Bipolar Junction Transistor, that is BJT. Let's have an introduction of BJT. The transistor was first invented in 1948 by John Bardeen and W.H. Breton of Bell Telephone Laboratories, USA. Bipolar junction transistor is a three-terminal device whose operation is dependent on the interaction of both majority and minority carriers. Hence, it is known as a bipolar device. The advantage of BJT over other old electronic equipments are long life, efficiency, lightweight, smaller in size, smaller power consumption, etc. The transistor is a basic building block of all modern electronic systems. In this, the output voltage, current or power are controlled by the input current. Therefore, it is also called a current control device. Now we come to BJT symbols, terminals and its construction. A transistor consists of two p-n junctions formed by sandwiching p-type or n-type semiconductor between a pair of opposite types. Here in the figure we can see in an NPN transistor, p-type semiconductor is sandwiched between two n-type materials, and in case of PNP transistor we can see n-type semiconductor has been sandwiched between two p-type semiconductors. A transistor can be classified in two types based on its construction. First one is NPN, as we can see in the figure, and the second one is PNP. A transistor in which two layers of n-type semiconductors are separated or sandwiched by a p-type semiconductor, that is known as an NPN transistor, and a transistor in which two layers of p-type semiconductors are separated by a thin layer of n-type semiconductor, that is known as PNP transistor. These two types of transistors can be clearly seen from the figures, and we have also shown the symbols of both NPN and PNP transistors. The arrow head shows whether it is an NPN or a PNP transistor. The arrow is always placed on the emitter side. If the arrow is pointing outwards, that is the current flow is outwards, the transistor is NPN. If the arrow points inwards, that is the current flow is inwards, the transistor is PNP. Now, there are two p-n junctions, as we can see in a transistor, which may be regarded as a combination of two diodes connected back to back. As we can see, the middle section is very thin layer. This is the most important factor in the function of a transistor. The main application of a transistor has that it has a very important property, that it can raise the strength of an weak input signal. This property is called amplification. Due to this quality, a transistor is one of the most widely used semiconductor devices. At present, transistor is used in almost every field of electronics. Its few applications are: it is used in control system, transistors are used in satellites and mobile phones, in digital computers, electronics, the transistors is used as a high-speed electronic switch. In communication systems, it is widely used as the primary component in the amplifier. Now, the transistors has three sections or three terminals. First is emitter, that is this one. Second is base, that is this one. And the third is collector, that is this one in the figure. Now we come to the emitter section. The section on one side of the transistor that supplies large number of majority carriers. In case of NPN transistors, it is electrons, or in case of PNP transistors, it is holes. That is called the emitter. Since the emitter supplies or injects a large amount of majority carriers into the base, so it is heavily doped but moderate in size, and it is always forward biased with respect to the base. Now we come to the base. The middle section of the transistor is called base, and it is very thin and lightly doped region. The base emitter junction is forward bias, allowing low resistance for the emitter circuit. The base collector junction, this one, is reverse biased. That is, it offers high resistance in collector circuit. Now we come to collector. The other side, that is the collector, collects the charges, so it is called the collector. The collector is always reverse biased, so it is called the collector is always reverse biased and offers high resistance in the collector circuit. The doping level of the collector is between the heavily doped emitter and lightly doped base. The collector region is physically longer than the emitter region. So, heaviest doping region is the emitter, largest region, that is physically large region, is collector, and the smallest region is the base. Now, transistor action. The method of applying external voltages to a transistor is called transistor biasing. The transistor operates in 3 different regions based on biasing of a transistor. Okay, first one is active region. In this case, the emitter base junction is forward biased and collector base junction is reverse biased. In this region, transistor is used for amplification. The collector current is dependent upon the base current. Next is the saturation region. In this case, both junctions are forward biased, and in this region of operation, the collector current becomes independent of the base current. Now the transistor acts like a closed switch. Then comes cutoff region. In this case, both junctions are reverse biased. In this region, the transistor has zero current because the emitter does not emit charge carriers into the base, and no charge carriers are collected by the collector except a few thermally generated carriers. Now the transistor acts like a open switch. The next and the last one is the inverted region. In this case, the emitter base junction is reverse biased and the collector base junction is forward biased. In this case, the transistor is said to be operating in inverted region. Now we come to the operation of an NPN transistor. Figure shows an NPN transistor. As we can see, the base emitter junction is forward biased by a DC source. This is the DC source. Thus, the depletion region at this junction is reduced. The collector to base junction is reverse biased, as we can see from the figure. Hence, the depletion region at the collector to base junction is as shown in the figure. Now the forward bias emitter base junction causes the electrons, which are the majority carriers in the N-type emitter, to start flowing towards the P-type base, as you can see in the figure. This constitutes the emitter current, that is IE, as these electrons flow through the P-type base. They tend to combine with the holes in the P region. We know that the base region is very thin and lightly doped. As the base region is very thin, it means that the number of holes present in the base region is few. Hence, the injected electrons into the emitter, only a very few electrons recombine with the holes in the base region. That's why we keep the base region thin, so that minimum recombination of electrons and holes takes place. Now this constitutes the base current, that is IB. The base current is very small as compared to the emitter current. Now the remaining large number of electrons cross the base junction and move through the collector region to the positive terminal of the DC source as shown in figure. This constitutes the collector current, that is IC. However, the emitter current is the sum of collector current and base current. That is, emitter current is equal to IE. That is, the emitter current IE is equal to IC plus IB. The collector region, the collector current is slightly less than the emitter current due to the fact that 2 to 5% of the electrons are lost in recombination process which has been taken place in the base region. The collector current IC is a function of emitter current IE with increase or decrease in emitter current. There is a corresponding change in collector current. Here we can see the formula IE, that is the emitter current, is equal to the sum of base current IB and the collector current IC. Now we come to transistor configurations. A transistor has 3 terminals, as you know: emitter, base and collector. We require 4 terminals when a transistor is to be connected in a circuit. 2 for the input and 2 for the output. This is achieved by making one terminal of the transistor common to both input and output terminals. The input is fed to this common terminal and one of the other 2 terminals. The output is obtained between the common terminal and the remaining terminal. Transistor is configured based on the common terminal. So we have 3 configurations of a transistor. First is common emitter configuration, second is common base configuration, and the third is common collector configuration. Now what is common emitter configuration? As you can see from the figure, in common emitter configuration, the emitter terminal of the transistor is made common to both input and output. The input is applied between the base and emitter, and the output is obtained between the collector and emitter. This configuration is widely used for many applications like amplifications or amplifiers, switching circuits, etc. Next comes common base configuration. In common base configuration, as you can see, the base terminal of the transistor is made common to both input and output. In this, the input is applied between the emitter and the base of the transistor, and the output is obtained between the collector and base terminal of the transistor. Next and the last is the common collector configuration. In common collector configuration, as you can see from the figure, the collector terminal is made common to both input and output. The input is applied between the base and collector terminals, and the output is obtained between the emitter and collector terminals. It is also known as emitter follower. So this was our today's discussion. In the next class, we will discuss about the leakage current in a common base transistor, leakage current in a common emitter transistor, then DC current gain, AC current gain. Then we will also discuss about the characteristics, that is the input and output characteristics of transistors for various configurations. So after today's class, you can easily explain the operation of the transistors. We have discussed here NPN transistors. You can easily explain the operation for PNP transistors also, and you can solve simple problems regarding these concepts. Thank you.